Hello everyone, I am Sunanta from SNS College of Technology, Department of Mathematics. As the continuation of the lecture series in the topic testing of hypothesis small samples, in this lecture video we are going to see chi-square test for goodness of fit. So here is the small recap of the previous videos in which we have seen t-test and f-test. So in the t-test we have seen single mean and difference of mean. In the f-test we have seen difference of variances, that is a comparison of variances of two populations. So here in this chi-square test we are going to see the goodness of it, which one is the best method like that. So let us see what is pros and cons of chi-square test. So here it identifies deviations. So it detects significant differences between observed and expected distributions. Next is informs decisions. So this guides decisions in quality control and in traffic engineering. This enhances efficiency. So it improves manufacturing and traffic management efficiencies. Now each and every method have pros as well as cons. So let us see the cons of this method. That is, this requires large number of data, so needs substantial data for accurate results. So few data cannot be enough to calculate the goodness, so we need large number of data to calculate. Next is sensitive to assumptions. So this solely relies on correct assumption about expected distributions. Next is empathy part. So misinterpreting statistical findings. So lack of empathy leads to misinterpreting statistical findings. So next, second one is acknowledging systemic racism in healthcare. So this empathy helps in identifying or understanding systematic approaches to things in healthcare. Next is ignoring lived experiences. So ignoring live experiences results in incomplete data interpretation, which may also result in the wrong decisions. Next is framing result responsibility. So empathy ensures responsible framing despite limited conceptual understanding. So here is the defined part in which categorical data is first fine. So that is, understanding the nature of the data is crucial to apply the test correctly, whether to use a t-test, f-test or chi-test. Next is an observed frequency. So there are the actual counts for the sample. Next is expected frequency. These are the theoretical counts based on the null hypothesis. Next comes the null hypothesis. So null hypothesis test for possible rejection of the claim. Next is an alternative hypothesis. Next is degrees of freedom. So this value is used to determine the critical value. Next is the significance level. So this sets the threshold. Next is the p-value. This indicates the probability of observing the results under the null hypothesis. Next is the ideate part, in which how well the sample data fits in the hypothesized distribution. That is, data supports hypothesis, small test statistics and large p-value. If data does not support the hypothesis, then large test statistics and small p-value is used. Next is the activity part, in which we can see two questions. So which scenario best fits a chi-square goodness of fit? So testing if two categorical variables, so gender preferences. Second one is determining if observed frequency of a single categorical variable match an unknown hypothesized distribution. Next is comparing means of two groups. Next, assessing correlation between two continuous variables. So here the answer will be B option. A key assumption for the chi-square goodness of fit is that all expected frequencies should be greater than 5. So here is the application part of chi-square. So let us see where we can apply this chi-square goodness of it. So in manufacturing, quality controls, so to identify the machines producing this inappropriate defectives, so to test the defectives. Next, in material sciences, to validate or refuges normal distribution of material strength. Next is to traffic engineering, so which reveals patterns in accident distribution across days. Next is software testing, so verifies uniformity of random number generations. Next is the mind map, in which chi-square goodness of fit. So first we have seen the purpose where we can use. Next is the calculation of the values. Here we use the formula summation OI minus EI the whole square divided by EI, where this EI stands for expected frequency and OI stands for observed frequency. Next, key requirements are maximum expected frequencies. Next is p value and all. Next, distribution, and we'll interpret the result as in the previous methods. We'll compare the test statistic value with the critical value, which in turns gives the conclusion for the method. So here are the references. Thank you.